Armando Surigan, Biology and Medicine videos. Please make sure to subscribe, join the following group. For the latest videos, please visit Facebook Armando Surigan. Please like, and here you can also ask questions, answer questions, and post interesting things, including your artworks. And you can also change the quality settings to the highest one for better graphics. In this video, we're going to talk about glucocorticoids, which is a steroid hormone, and it's used mainly to relieve pain for most people in the long term. Glucocorticoids have powerful anti-inflammatory effects, but also is immunosuppressive. Now, glucocorticoids are actually produced naturally by the adrenal glands in our body. These are known as, this hormone is known as cortisol in this case. However, glucocorticoids can also be synthetically made and injected or taken orally. Some example of these are hydrocortisone and prednisone. And you might know this because some, especially sports people, they use cortisone to relieve pain quickly for a duration of time. But of course, taking glucocorticoids like this for a long time has some very bad effects. Now, because glucocorticoids are a steroid hormone and so is lipid soluble, they have to transport around the blood bounded by a protein. This protein is a carrier protein for glucocorticoid known as transcortin. So transcortin is essentially binds and transports glucocorticoid around our body to specific locations. Now let us see some effects glucocorticoids have in our body. Remember, they are powerful anti-inflammatory drugs, and also they are immunosuppressive. So it would revolve around these two things. One of the main things glucocorticoids do is that they go inside a cell and bind onto a glucocorticoid receptor and upregulate and downregulate certain genes. So here we have a cell. It can be any type of cell. Here we have the cytoplasm of the cell, and here we have the nucleus of the cell containing the genes. Before we see what glucocorticoids do, let's see what normally happens during inflammation, pain, and infection. And look at this in an overall picture. So when we have pain, inflammation, and infection, this will stimulate this cell through the receptors by chemicals or something. And essentially, this will activate nuclear factor kappa B within this cell. Nuclear factor kappa B will then activate the genes of this cell to produce mRNA. The mRNA will be translated to inflammatory cytokines, or will be translated for inflammatory cytokines to stimulate or to promote the inflammatory response. And this may cause sensitization of pain, heat, redness, etc. So this will promote inflammation, the response. So what does glucocorticoids do? Well, as mentioned, glucocorticoids will upregulate or downregulate certain genes. And for an example of this is that glucocorticoids, which is a lipid-soluble hormone, will travel around the body with transcortin. The glucocorticoids will enter the cell and bind onto a glucocorticoid receptor. Then this glucocorticoid receptor with the glucocorticoid will then essentially inhibit nuclear factor kappa B's activity, which will make nuclear factor kappa B inactive, and thus will not produce inflammatory cytokines, will not produce inflammatory chemicals, and so will suppress inflammation. And this is why glucocorticoids is a powerful anti-inflammatory drug. This is just one example. Another thing glucocorticoids will do is that it will inhibit the formation of inflammatory mediators carried out by certain enzymes. So an example of this is that when we have inflammatory response, the phospholipid membrane of cells, certain cells such as white blood cells, will be converted to arachidonic acid by a membrane-bound enzyme phospholipase A2. Arachidonic acid will then be converted by the enzyme COX to prostaglandins, leukotrienes, or thromboxanes, and these are eicosanoids. All of them are inflammatory mediators. What glucocorticoids do is that they will essentially enter the cell and inhibit the enzyme phospholipase 2 and COX enzyme, thus inhibiting the formation of inflammatory mediators. So glucocorticoids inhibits phospholipase A2 and COX. Thus is an anti-inflammatory agent. Glucocorticoids, remember, travel around the body bound to carrier molecules such as transcortin. Another use of synthetically made glucocorticoids such as hydrocortisone and prednisone is as a replacement therapy. Because remember, the adrenal glands normally produce cortisol glucocorticoids. However, when the adrenal glands produce low levels of glucocorticoids, and we need glucocorticoids, an example of this sort of disease is known as Addison's disease. So we would use replacement therapy and inject glucocorticoids into this person, and thus try to balance low levels out. Now, there were like the good effects, sort of using glucocorticoids as an anti-inflammatory drug and as a replacement therapy. However, there's always side effects with using any type of drug. For glucocorticoids, the long-term effects include immunosuppression, and so the person using it for a long time can be more prone to infection. Here is a bacteria, for just a note. So, for example, here we have all the white blood cells, some white blood cells, the T cells, mast cells, dendritic cells, and macrophage. Using glucocorticoids for a long time essentially decreases the number of white blood cells and the production of these cells. And this is related to the decreased cytokine production as well, because remember, glucocorticoids reduce the production of inflammatory mediators. Long-term use can also lead to Cushing's syndrome, which is related to Cushing's disease. However, Cushing's syndrome is unrelated to the other endocrine glands. It's just because we use too much glucocorticoids. Cushing's syndrome, a person suffering from Cushing's syndrome, we would see weight gain, obesity, and fluid retention. And so you have this sort of big gut because of the fluid retention. And I'm highlighting fluid retention because the synthetically made glucocorticoids, such as like hydrocortisone and prednisone, they also act sometimes or slightly like mineral corticoids. An example of a mineral corticoid is aldosterone, and aldosterone causes fluid retention, and this is why we see fluid retention in the use of glucocorticoids. Finally, a main point to make is long-term glucocorticoid use can affect the bone and can lead to or cause osteoporosis. We have two types of cells, main ones, in the bone, associated with the bone. We have osteoblasts, which essentially builds bone. And then we have osteoclasts, which essentially break down bone. Now, what glucocorticoids do is that they actually inhibit osteoblast activity and formation, and they promote and stimulate osteoclastic activity. And so, this can lead to osteoporosis, because osteoporosis is weakening of the bone, leading to fractures. I hope you enjoyed this video on glucocorticoids. They were just an overall examples of the effects glucocorticoids have on the body.